Oh, you can't see my screen. I'm so sorry. Let me see if I do that. Do you see my screen now?
Yeah.
Okay, optimization. So today we're gonna deal with optimization. So we already did with last one. So optimization 2. Last time we deal with this questions, which is what happened is 0, and we graph it, we can find out it's 4.042. Or you can graph this original function, find out what the maximum is, but the goal is actually use calculus, which is take a derivative of this function, set it equal to 0, and then therefore like you can do that, right? Can you do that? Should be able to do, right? Okay. So we did this one. So, and today we're going to look at these questions here. How do we apply the mathematical process into a mathematical modeling process? Because we always have to model something. Mathematical model is probably very, very important. Some of you guys want to be a biomedical engineer. I think Kevin want to be a biomedical, right? Something like that. I think there was something, a mechanical engineer around here. Was somebody here or no? Doctor? What do you? What do you want to do, Ethan?
Something in like probably biology.
Probably biology. Oh, okay. I'm disappointed about that. I'm just kidding. Dashin want to be what?
Computer science and electrical engineering.
Okay. Sounds very, very fancy. Sarah Z, what do you want to be? Something in computer science. I would think like you would be a doctor. That's your second option. Okay, that's cool. That's cool. Sarah Jung, what do you want to be? Architectural engineering? Okay. Katie, you don't know yet. I remember I asked you several times.
I don't know. Maybe something like physical therapy for like kids or something like pediatrics.
Oh yeah, you definitely don't need calculus. I'm just kidding. Sydney? Pediatrician. No, that's nice. You gotta be more talkative though to the kids.
Oh no, she's talkative, just not in the class.
Just not with me. She just doesn't like me. That's okay. No offense taking. I won't like myself either. So what we're gonna do is we're gonna show you these questions, and we're gonna, because I'm too lazy to type. Can you tell? So obviously this is example 1, but last time that was example 1. This one is a different example. So this one has something to do with this. Okay. So a manufacturer want to design a open box, have a square base and a surface area of 108 square inches. Shows a figure 3.53. I didn't show you what 3.53 look like. What dimension will produce a box with maximum value? Okay. So first thing, let's write down a procedure to do this type of questions. And procedure is understanding how do we do mathematical modeling. So we can scroll down here. So the procedure for optimization problem. If I know how to spell. Optimization problem is find equation. Oh, first of all, sorry. Let me talk about different thing. Let's talk about draw pictures first. So draw a pictures that have assigned variable. Okay, so draw a picture with some type of assigned variable. Second thing is find what you try to optimize. So what do you try to optimize? Okay, So you optimize could be a lot of things. If you are a company, you want to reduce the costs, increase the productivities, doing things, reduce the material use. Those are optimized. Optimize the profits, if you're in terms of company. So you can do a lot of those things. So find what you try to optimize. In this case, we are trying to optimize such certain situations. Okay. 3. Find the constraint. Find constraint. What is constraint? Well, if I build a water bottle, right, and I need to pay attention on what is how much material I want to use. So I give you a certain amount of material I want to do from each bottle. I want to try to build the biggest volume. So I can try to optimize the volume of this so kids can enjoy, have enough water, stay hydrated, and things like that, nature. So sometimes I don't want to build a big, huge bottle I can even barely carry, because I have to consider it could be a weaker person cannot carry a big bottle, or something like that. It's just certain, in business world, there's a lot of things to consider, right? You cannot just consider a certain perspective. Are the product for man or woman? The product is, color matter at that case, or things like that. So find some type of constraint. And constraint usually deal with, so this one usually deal with something called primary equation. And this one used to do with secondary equation. Now, if you remember that you did last time on related rate, and that's what we talk about this after related rate. We did have a constraint on related rate. For example, the cone question. Remember, you had to use the ratio of the radius and the height, and equal to the cone's radius and height, the actual cone radius, and use that as a similar triangle relationship to reduce the variable. So you find the constraint is to find a secondary equation, and the goal is to reduce the variables. So the goal is to reduce the variables, because you don't want to take a derivative of two different variables, x and h, or whatever, x and g, whatever it is. So you want to take a derivative. It's only one single variable I can take a derivative. So constraint. Second, the fourth step is to reduce the variables, right? Reduce the variable by insert the constraint. Insert the constraint into the primary. Why do we insert? When we insert that ratio of r and h in there, we reduce a variable when we take a derivative of. Fifth step is take a derivative and set it equal to 0. Why? Because set it equal to 0 is you finding a maximum and minimum, or minimum, and depend what the situation you want. It could be a maximum, could be minimum. I want to minimize cost. I want to maximize value. I could have do both. I don't have to do a single thing. So number 6, and solve the problem. Answer the questions, right? Answer the questions. Remember, sometimes the question could be says, what is the value? Or what is the dimension, right? So it really depends on what the question is asking. You gotta make sure you answer the questions. You cannot just say, okay, well, they ask you, what is the dimension? And you give them the volume. And or the question says, ask you what's the maximum volume, but you give a dimension. Dimension's not answering the questions, right? So you want to make sure you answer the question when you deal with this kind of questions. Got it? Okay. Let's look at this question. A manufacturer wanted to design open top, and I'm going to teach you how to annotate something. Annotate something, design open top with the square base. That's a key thing, square base. And the surface area, this is kind of exciting, surface area of 108.
Is that including the top, or since it's open, it's not including the top?
Open means no top,
Oh,
or could be no bottom, has top.
oh.
If you turn around, it'll be that way. But it's the same box. Produce a box with a maximum value. So I color code 3 different color here. And the reason why they are different color is there are 3 piece of things. One is primary, one is secondary, and one is what do the answer want, right? All right, let's do this. Do we have a picture? We'll draw one. Let's draw one. We have a square base, right? The key thing is a keyword, square base. Why is square base highlighted? It could be any kind of box. It could be a cube, could be a rectangular prism, could be anything. But in this case, only square base, but it's not a cube. If a cube, then it's easy. Your life is easy, right? Is that gonna be a very, very easy question? Absolutely. But a square base, kind of interesting because the way they say square base. So I'm gonna draw a square base. I know this is not a square, but this is 3-dimensional. So something like that. And the square base, so that means the bottom base is going to be a square. If I look at just only the bottom part, if I look at the bottom part here, it's going to be a square. It's going to be a square. Okay, this is the base. Now, if a square, they must have what? Equal length, right? So what would be the value of this box? That's a good question. We're going to assign some variables. We're going to say this is an x. This is an x. Would you agree? Because it's square base. Is the height the same as a square base? Not necessary. So we're going to say that is the height. So can you tell me volume of this box is if I give you this much help? Somebody?
That's cubed.
No.
Wouldn't it be HX cubed? I mean,
No.
X squared.
Wouldn't it HX squared?
Yeah, HX squared.
HX squared, good. Why? Because x squared is the base multiplied by the height. So a base times height, that's a rectangular prism. Got it? Now, what you're going to do is think about the next piece of information. We already take care of this, and we also answer the questions. Is what we're trying to maximize. We're trying to maximize the volume, right? We're trying to maximize volume. So we are maximize this. We are trying to maximize the value. What's a nice piece of information?
It gives you surface area.
It gives you surface area. Holy shit. So surface area is 108. Right? Surface area is 108. So, what is 108 equal to? Caroline? No?
Doesn't it equal x squared?
Wouldn't it be? Wouldn't it be
Be like,
X squared for H?
No, there's 5. Because we open
Kevin?
We can put it as x squared plus 4hx.
That was the same thing as Katie? Is that right? Dashin, do you have different opinion?
I was gonna say 5x² because the top is open, so
5x squared?
Well, what would you, what about H?
h. Oh,
Because our sides are.
okay, so h
Yeah, that's what you're saying. X squared times 4hx, or like plus 7.
Okay, so I would say it's a very good job that you have x times x. This is the base, right? But there is a 4 lateral, so it's 1, 2, 3, 4, right? There is 4 lateral, and those lateral is at the side. The lateral is called lateral face, by the way. It's not a top and bottom. Lateral is like this is called a lateral face. So laterals, there's 4 sides, but they all have the same width, which is x. But they have different length, which is height. So there's 4 times the hx, right? So x is on the bottom, h, right? So those times 4. Does that make sense? They're 4 times. So 108 is equal to x squared plus 4xh.
Oh, so you're right.
Yep, you guys are right.
Oh.
So this is called a primary, and this is a secondary. Okay, we're gonna call it secondary. Now, what's the goal of a constraint? See, the constraint is 108. It's constraint the material I'm using. I don't want to use more than 108, but I want it to be constrained. So what in this case here, what do we use constraint for? What we try to do with the constraint? No. What do we talk about when we use constraint?
Reduce the variables.
Reduce variable. How do I do that? I have this constraint here. How do I reduce a variable?
Take the derivative.
No.
You can take out an x, but that wouldn't help.
You want to take out x? Yes, that won't help. Good thing that you see that.
We could like isolate a variable on like one side so it equals that if you want to plug it.
Isolate which variable?
It might be a little easier to isolate h, I think.
Exactly. It's not possible to isolate the x, but it's always possible to isolate h. So it'll be 108 equal to minus x squared equal to 4xh, right? Can I divide by 4x on both sides? Yep. H is equal to 108 minus x squared over 4x.
We've got a winner for you to sneeze. Sorry for
So now what we're gonna do is we're gonna replace this. We're gonna put it right here. We're gonna replace right here. Why do we do that? We reduce the variable. You see that? It's x squared times 108 minus x squared over 4x. You see that? What variable do you have left? Just x.
What happened?
I have something in my throat. So can I distribute this? Yeah. I can cancel out one of the x, so it'll be x equal to 108 minus x squared over 4. So it'll be 108x over 4 minus x cubed over 4. Does that make sense? And that's equal to 27x minus x to the 3 over 4 value. This is the same equation of what we tried to model yesterday with a different situation of cutting a corner. This is the equation can model me anything. what happened when x equal to 5, what happened x equal to 10, but also including the constraint. Now, if you do realize, yesterday's question also have a constraint. Yesterday's question constraint is 21.5, 21 minus 2x, as well as 29.7 minus 2x. That was the constraint. And we plug into the primary because we discovered the constraint. Constraint in that situation a little bit easier than this one. This one is a little bit harder. Am I going too fast? Now, what am I doing after that? Take a derivative. You're just stealing Kevin's thunder.
Honestly, Katie.
Jeez. So impolite. He raised his hand. I'm just
Oh.
kidding.
Talks for them.
I'm just kidding. I just want to make Katie feel uncomfortable. It's okay. I'd rather you steal her standard than he's stealing everybody's standard.
What was I doing?
Nothing. I just want to make fun of you. Okay, so v prime is equal to 27 minus 3 over 4x because I take it down to 3. So, and I'm just set it equal to 0, equal to 27 minus 3x squared over 4. 27 equal to 3x squared over 4 because I get rid of negative sign on both sides. 108 equal to 3x squared times 4 on both sides, divided by 3 on both sides, 36 equal to x squared, x equal to 6 plus minus 6. Of course, it's not negative 6 because of physical restriction. You're not going to get a negative box, right? Physical constraint says you had to use the positive 6, not negative 6. Did I answer the questions? That's my second question. My third questions. They say, what the question says, they say what dimension will produce a box with maximum volume. So we just want to find a dimension. So how do we find the dimension? Take the 6 and plug it back into the 108, right? 108 equal to 6 squared, so it'll be 36 plus 4 times 6 times h. So that'll be 108 equal to 36 plus 24h. And 72 equal to 24h. H is equal to 3. So it'd be 6 times 6 times 3. Yes,
Where'd you plug in the 6 into?
into this one here. The constraint equation. So I answer the questions. Now I want to verify something at its maximum and minimize. So we talk about a second derivative test. If I do second derivative test, that means I can take second derivative. So v double prime is going to be negative 6x to the 4th. Right? If I take a second derivative, that 27 just goes away. The 2 is going to come down, and I'm going to plug in 6. So negative 6 times 6 over 4 is equal to negative number. If it's a negative number, it's concave down. If it's concave down, it's a maximize. There you go. We solved for a second derivative test. Got it? Understand it? Now you do it. Wait, should I wait for you? I should wait for you, right?
So like the final answer is 6 times 6 times 3.
Because they asked the dimension. If they asked the volume, then you had to work it out the volume, right?
Do you want us to write like something else like in addition to that, or just like say the dimensions are 6 by 6 by 3?
But it depends on the question says. If it's a dimension 6 by 6 by 3, it's a perfect answer.
Okay, I didn't know if you wanted to like use.
And I also verify by using second derivative.
Okay.
And that second derivative test is kind of important in here because it's much easier to do second derivative rather than do a normal line test. I think so much writing. If I do second derivative, that's one step. And I can do it inside my head. It's very easy. So that's why I said second derivative test is also important as well. Here's your question. Supposedly you have 108 meter of fence to make 2 side-by-side enclosure as shown. What is the maximized area that you could enclose?
Okay, so we're doing number 5.
So we want a 2 enclosed thing. Now the thing is about the fence in the middle. You don't need to build double fence. You just need to build one fence to save materials. So that's why you don't build a two separate squares. You want to join two squares to reduce one side of fence. So those are things that you should think about. Should I give you answers too? No. I shouldn't give you answers? No. On your homework, you have answers. You cannot see? Oh, you don't have to write down. Sorry. I just want to make sure your eyesight, no problem. Like Dashan still cannot see with glasses.
Are you okay?
Dashan's like, what is this?
What question are we on?
Question 5.
Okay.
So we're only doing one fence. Do we have 51 meters of fencing?
Huh?
It says we have 102 meters of fencing to make 2 side-by-side enclosures. But you said we only made 1, right?
Well, it just fence as a draw like right here. So the middle part is only one fence, yeah.
Oh, wait, oh.
There's a drawing over there, by the way.
Wait, are those
Here.
rectangles?
They're not any type of shape. You decide the shape. They could be rectangle.
Is it three-dimensional?
It's not 3-dimensional.
So
Well, it could be 3-dimensional in the term of fence. Yes, it's 3-dimensional, but the structure is kind of like only 2Ds.
okay.
So length and width, pretty much.
Okay, so at the top, are those like the same like length? Or, like, at the,
Well,
like,
they
the very
say
top of the fence, is that like the same? If they're 2 side-by-side enclosures, does that mean they're identical or no?
I don't know what you meant.
I don't know.
She's saying, are the 2 enclosures supposed to have the same dimensions?
Yeah.
Yeah, well, ideally, in order to maximize, usually they are the same dimensional.
Okay.
Yeah, it gets kind of hard if I give you, like, there was a question on question 7. They say a piece wire is 40 centimeter, cut into 2 pieces. One will build a circle, one will build a square. Woof, those one are hard. Those one are out of this league, but. Assign some variable. The like vertical line should be the same. The horizontal line should be the same. They are symmetricals, yeah. It's not gonna maximize if they're not symmetrical. At least I don't think so. Do you guys need some type of help?
Yeah.
Yeah?
For area, did you get x squared?
No.
X squared. Oh, but what are your variables?
X.
You can't use X, they're not the same length. It's not a square. So this length isn't the same as this. No. But this length is the same as this length, it's this length, and this
Yeah.
length here is the same as that length.
Oh, okay, so
So you have to use like a different variable, so you can use like H or Y, whatever you want. It looks like a square, but it's a rectangle. Or it could be a square.
So this is not very symmetrical, but yeah, you got an idea. It's probably something like this. I don't know why it's straight up like me. For me, it's probably something like here. How do I assign variables? You gotta be careful. You got a fence here. There is a y, there's a y, and there's a y here.
And then at the top you can say it's like,
You can say the whole thing is x, or you can say half the thing's x. I do this way, and you can do it the whole thing is x too. Really depends. And you're gonna get the same answer regardless because you draw a picture that way. What will be the area here? What we're trying to maximize, the area or the fence?
the area,
The area. So the area equation is gonna be what?
X terms.
2xy. Right, x times 2y, same thing as 2xy. The perimeter is 102. So what's 102 is equal to? Nope.
I said 3x plus 4y.
Yeah, I said 3x plus 4y.
Cause you have to like add.
Oh, I say 4x plus 3y because of the way I assign variables is kind of different.
Yeah.
Oh,
Yeah,
But that's me, but it could be assigned the other way, so it doesn't matter.
yeah, I signed everything.
As long as your drawing is based on that makes sense for you. So those are the two equations I need. Then this one is called constraint. This one's called a primary. So primary, secondary. On your test, even you write out primary or secondary, I can give you half of the credit. But that AP exam doesn't give you that. So I'm gonna say 3y is equal to 4x, and now divided by 4. It should become 34 minus 3 over 4y is equal to x. And then I'm going to substitute in here. You should get 433.5 as the answer for the area. And I'm sorry I ran out of time, but I'll try to make a whole video of it. But yeah, you should end up to be the same. If you substitute back in, work it out for today's homework. You will have homework today about maximize, minimize.